right, notes 5.1. This is the beginning of chapter 5, obviously. And this first lesson is just a review of what you have done before in algebra. You may not remember, or you might. We'll see. Okay, so I'm going to, cross off A and D. No need to do all those. I actually want to do C first. So up here at the top, I have an f of x and I have a g of x. So I'm going to put 4 on C. I'm going to put 4 into g of x because it says g of 4. And I'm going to put 4 in for the exponent. So I'm going to do 1/3 to the 4th power. So now I'm going to take both of these numbers to the 4th power. So I get 1, and then 3 to the 4th is 81. So that is my answer to C. Alrighty, so on B, now I'm going to use f of x because it says f of -5. So I'm going to put -5 in for x. So I'm going to take 2 to the -5th power. Well, I can't have negative exponents if you recall from chapter 4, the beginning of chapter 4. So I need to do the reciprocal of my base. And then once I do that, my exponent becomes positive. And then I'm going to take both of those numbers to the 5th power. So I get 1/32. All right, so like I already mentioned, we are going to be working with exponential functions, and that is where x is an exponent. So out of all these options down here, it looks like D would be an exponential function because x is the exponent. Okay, so now we're going to start graphing exponentials. Looks like 4 and 5 are kind of easier ones, so I'm going to skip 4 and 5. So that brings us to 6 on the next page. So we'll get to graphing in a second, now that I've crossed off those first two. Okay, so the reciprocal of B is 1/b. Or I could say that it's the same thing as b to the -1st power. So if I have y equals 1/b to the x, it is the graph of y equals b to the x, but just reflected across the y-axis. So what does that mean? Here's an example. Exponential growth is where our base is in between, whoops, that's not right, is where our base is greater than 1, and it's going to look something like this. Exponential k, well, they pretty much look the same, except this time my base is going to be in between 0 and 1. So this would be exponential decay. So as you can see, they just reflect, they look the same, but they're flipped. They reflect over the y-axis. So the graph of 1/b to the x is the same as y equals b to the -x, because I just see the reciprocal of my base, which is 1/b, and that changes to a positive. Okay, so the reason why this is not exponential is because 0 to any power is 0. Whoops, I ran out of room there. So it wouldn't be growth or decay, it would kind of stay flat. Oh, actually I should go back to this one. 0 to any power is 0 except when the exponent is 0 itself. there's actually going to be a break in the graph. Okay, this is the same reason why this one's not exponential, is because 1 to any power is 1. And then on 12, I just want to do an example so it's easier to understand. So we're saying that we cannot graph this when our base is negative, basically is what I'm trying to say. So let's do an example. Okay, let's say we have this. So I'm just going to pick, let's see, I'm going to pick 2. What just happened? Hold on. Okay. I'm going to pick 2. I'm going to pick 1. I'll pick 3. I'm going out of order. Shoot. Let's do 2, 3, and 4. Because it defeats the purpose if I go out of order. Okay, so negative 2 squared is 4. Negative 2 cubed is negative 8. And then negative 2 to the 4th is positive 16. So the reason my base can't be negative is because it's not growth or decay. It's a positive, then a negative, then a positive, and it's going to be a negative, and it's going to alternate. So it's going to look something like this. It's going to go positive, then negative, positive, negative, etc. So it's not growth or decay. So these three, so I can't have a base that's a 0, I can't have a base that's 1, and I can't have a base that is negative because it's not growth or decay. Okay, if that doesn't make sense, it's not that big of a deal. The most important part is how to graph these. So let's go ahead and start with 16. We'll start graphing from there. So notice that x is the exponent. So whenever x is the exponent, I want to make a table. And I'm just going to use 3 numbers. I'm going to use 1, 0, negative 1 every time for x. So 3 to the first power is 3. 0, or any number to the 0 power is 1. And then I have a negative exponent. So what's going to happen is that my base flips and then it becomes to the first power. So if this is a negative 1, the y value is just going to be the reciprocal of your base every time. Okay, so now, since x is the exponent, I cannot cross the x-axis. Let me draw that in there. I can't cross that line. So I'm going to go and plot those points. So I got 1, 3. I got 0, 1. And then I have negative 1 up a third. So if I plot these points, looks like it's exponential growth. And make sure you don't cross the x-axis. Okay, 17. So it looks like first I have to move my origin. So this means I'm going to go up 1. So my origin moved up 1. Therefore, this is my new x-axis. And now I'm going to make a table. But I don't have that 1 anymore because I moved up 1. And again, I'm going to use the same x values every time. 1, 0, negative 1. So I'm going to take 1/2 to all of these powers. Again, this 1 is gone now. I moved up 1. So 1/2 to the first power is 1/2. Anything to the 0 power is 1. If my exponent is negative 1, I just do the reciprocal of the base. So if I flip 1/2, I just get 2. So now I'm going to plot those points from my new origin. Over 1 up 1/2, 0, 1, negative 1 up 2. And then I connect. So there is number 17. So the first one looked like it was exponential growth, and the second one is exponential decay. All right, moving on. Okay, so let's go ahead and I'm going to skip number 19. Okay, so number 18, we are going to first of all move our origin. So we're going to go down 2 first of all. And so that is my new origin. So therefore, I'm going to draw in my new x-axis here. Okay, so now that number's gone. I went down 2. Since x is the exponent, I'm going to use 1, 0, -1 in the x column. And then I'm going to have 2, 1, and 1/2. This is always going to be 0, 1. This is always the base. This is always the reciprocal of the base. So now I'm going to plot those points from my new origin. And if I connect, I get exponential growth. Okay, 19 is gone. Actually, before I do 20, I want to do 22 just because it's the same equation. So I'm going to do a lot of going back and forth here. So this is the same equation that I had back up on 18. So I want to find the domain. Those are the x values. So if I look, I have an arrow on the left, I have an arrow on the right, there's no breaks in between. Therefore, every single time for exponential growth or decay, your domain is all reals. Okay, the range are the y values. This time it's not going to be all reals because it looks like on this one, this is the lowest my graph gets. So on the y-axis, the lowest it gets is -2. It doesn't actually reach -2. That's just as far down it goes. It's everything above -2. So my range is y is greater than -2. It's never going to be equal to because I can't cross or touch that horizontal line there. Okay, we'll do end behavior in a second, but if you recall, this is end behavior. Let's go ahead and do D first. So I just want to know if it's increasing or decreasing. Monotonic means it's one or the other. So if I look from left to right, my graph goes up strictly. So it's monotonic increasing. Okay, so when I fill these in, I have 3 options. It's either going to be positive infinity, negative infinity, or this time it could be a specific number. So as you recall, this means you're looking at the right side, and this means you're looking at the left side. So if I look at the right side, my arrow is going up. So this is going to be positive infinity. On the left side, though, my arrow is flattening out. It is flattening out to this number, which is -2. So it's always, so one of these are always going to be whatever number we wrote down for the range. All right, let's look at number 20 next, because we skipped number 19. Okay, so it looks like I got 2 things going on here. I'm going to go to the right one and then up 3. There's my new origin. I'm going to draw in my x-axis here. All right, so I don't have these numbers anymore. Now I do have a negative, so I'll have to pay attention to that in a second. But again, since x is my exponent, it still should be there. I'm going to use 1, 0, -1 for my x's. So I'm going to ignore this negative for a second. So next to 1, I'm going to put the base, which is 1/2. Next to 0, it's always 1. And then next to -1 is the reciprocal of the base. Okay, now I have a negative on the outside. Since this negative is not with x, the x's don't change, the y's do. So I'm going to make all these negatives. Okay, so now I'm going to plot those points from my new origin. So over 1 down 1/2, 0, -1, and then -1, -2. And I cannot cross that new x-axis. It's going to look something like that. So that technically is exponential growth as well, because it increases from left to right. So both 18 and 20 are exponential growth. Okay, let's come down here and do 23, since we're talking about this graph. So no matter what, anytime it's exponential growth or decay, your domain is going to be all reals, but your range is not. So if I look here, this time my graph does not get above this y value. This y value happens to be 3. So my graph is less than 3. The highest it could get is 3. But I can't touch that line, so technically it doesn't go to 3. It's everything below 3. Okay, I'll come back to C in a second, the end behavior. But now I have to write down if it is definitely monotonic. I just have to write down if it's increasing or decreasing. So from left to right, it is increasing. So since it's increasing, that means it's exponential growth. Okay, so now let's do end behavior. So on the right side, it's flattening out. It's flattening out to whatever this y value is. And we said it was 3. It's always going to be the number in the range. One of these is. And then on the left side, my arrow is going down. So this one's negative infinity. All right, number 21. I do have a negative, but I'll worry about that in just a second. I don't have to move my origin this time. I'm not moving left, right, up, or down. So this is my axis there. Doesn't change. 1, 0, negative 1 like usual. Okay, and again, I'm going to pretend that negative is not even there. Just don't even look at it. I can't even cover it up. There we go. So next to 1 is the base, next to 0 is 1, and next to the negative 1 is the reciprocal of the base. Okay, this time the negative is with the x. So the x's change to the opposite. So that becomes a negative 1, that becomes a positive 1. Over here, the negative was not with the x, so the y's changed. This one, the negative, is with the x, so the x's change. So I'm going to go ahead and plot these points. So I'm going to go from this origin. So negative 1 up 3, 0, 1, and then over 1 up a third. So we have exponential decay. Now you would think it might be growth because the base is greater than 1. But if you recall, if you have a negative exponent, you do the reciprocal of the base, and then the x becomes positive. All right, so that's page 3. Let's move on to the last page. I think the last page we're getting to our graphing calculator, but we'll get to that in a second. Okay, let's talk about some characteristics. So if you recall, this is exponential growth. This is exponential decay. The formula for growth might look something like that. Decay, it might look something like that. Continuous versus discontinuous. There's no breaks in my graph when I draw these, so they're both continuous. And I'll just abbreviate. All right, the domain for growth and decay are both going to be all reals, but the domain is not. Let me draw in the XY axis. Okay, so these are just the basic growth and decay graphs. So it looks like on this one the range is everything above 0, and this one the same thing, everything's above 0. So y is greater than 0 on both of these. Okay, well here's the x-axis. Neither one of them touch or cross the x-axis, so there are not any x-intercepts. But I am going to have a y-intercept. If you're not moving your graph up, down, left, or right, the x-intercept's always going to be 0, 1. If you recall, that's always going to be in our table, 0, 1. All right, asymptotes are lines that your graph cannot cross or touch. And that's why we drew in those, with my highlighter, I drew in those yellow horizontal lines. They've all been horizontal. Therefore, the asymptotes are going to be the x-axis. Or it could be the new x-axis. So it's always going to be y equals some number. All right, on this one, if I look at the right side of my first graph, it goes up. So y goes to infinity. On this one, I'm looking at the left side. It flattens out. And since this was my range, then y goes to 0. On this one, I'm looking at the right side. On the right side, it flattens out. So it goes to 0 because that's what we said our range was. And then on the left side, it goes up to infinity. All right, they're both going to be functions because they both pass the vertical line test. And they're both monotonic because the growth increases and the decay decreases. All right, so there's that. Now we're going to need our graphing calculator. Okay, so we've done this many times before. Here's one important information. It says that 0 represents the year 2000. So before I enter this into my calculator, I have to make this 3, this 4, this 5, and this 6. Okay, let's go and type that in first. So to type that in, we're going to go to Stat, Edit, and then you probably have something in there, so you just clear and enter. All right, so I got 3, 4, 5, and 6 in list 1, 7.3, 8.8, 10.1, and 12.1 in list 2. Okay, so now they're in there, and I'm going to answer the question. It says find the exponential model of best fit. So to do that, I'm going to go to Stat, Calc, Exponential. Let's see if I can find it here. It is 0. Actually, it's probably 10, but it says 0. So we're going to go to Stat, Calc. I'm just going to put number 0 because that's what it says. And you have to make sure you store it. So depending on your calculator, you have to put y1 somewhere. So on mine, I have to put it there. So this is where you do the vars, y bars, function y1, and then you calculate. Okay, so it looks like my equation is going to be y equals, and I want it to look like this, a times b to the x power. So 3 decimal places is fine. 1.179 to the x power. All right, then it says, what is the model's regression coefficient? I'm going to put them both down. R squared is 0.996, and then R is 0.998. Well, regardless of which one that we need, they're both pretty good. They're both pretty close to 1, so this would be a pretty good fit of finding data. Now, just by looking at this equation, I know that it's growth because my base is greater than 1. All right, now we're ready to answer these questions right here. So I'm giving you a year, and we said that since year represents 2000, I want this x value to be 10. So to figure that out, first I want to make sure my equation is stored. So let's see, 4.47. If I go to y equals 4, okay, it's actually in there because it starts with 4.47. Okay, so now that it's in there, I am going to find my answer. So I'm going to go to second trace number 1. looks like it's graphing. And then I'm going to put x equals 10. So 23.375. 23.375, and it's in millions. Now that's one way to do it, but sometimes it doesn't work. Sometimes it might give you an error. So another way to figure that out is to go back to your calculator screen, so second mode, and I'm going to put y1 there, and to do that I do vars y bars function y1, in parentheses I'm going to put 10, and we still get the same answer. This way is probably the better option because it's always going to work. Okay, and then finally the last one. This time I'm giving you passports, and that's a y value. So if you recall, the first row are the x's, and the second are the y's. All right, there's somebody at my door. Time out. All right, I'm back. Sorry, somebody's at my door. Okay, so I'm gonna go ahead and hit graph. I wanna see if that shows up, which I doubt it's going to. It's not. Okay, I gotta fix my window now. So I'm gonna go to window. My Y max needs to be at least 20. I'm gonna do 25, just so I can see it better. All right, now I got to find the intersection. And again, we've done this before. So second trace, intersect, and then I'm going to scroll over to where they intersect about. And then I'm going to hit enter 3 times. So when y is 20, x is 9.057. So x is 9.057. Now I have to write my answer so it makes sense. Well, the x values are the years. So since 0 represents 2000, 9 represents the year 2009. So 2009 is the answer.